Hi there, this is an update on the Glass Revolution project. I'm working on concentrated solar power to melt basically sand into whatever we want to build. It's a relatively complex project, but it aims to reduce carbon consumption in construction and actually enable us to build installations that can protect us against the negative effects of climate change and actually do some eco-restoration and some economic growth based on something else than carbon, which is very necessary. For that I've a rig outside which can hold a Fresnel lens for concentration of solar light. I have a spot focus and a linear one. I also can mount a mirror, and the whole thing can be controlled by a microcontroller. If you've checked out the other video about, let's say, the Google SketchUp model, where I have a 2D kind of printer type positioning system, and then in that I have the mirrors. Of course, you know, it's not known that that will be the final design. Of course, you know, you need a little bit more support and input for being able to do that. But in order to hack it together, to demonstrate it, I've been looking at this. This is the inside of an old ball mouse. So it's a USB mouse with a little, let's say, one of these black balls in it. So what they have is they have little encoder wheels that rotate, and there are, you see here the transparent side is where my thumb is a photo, is a LED. Infrared LED, and the black side is a infrared photodiode. And what it simply does, it counts the interruptions of the beam, and also the directionality, because it has apparently it has two sensors that do a differential measurement. The funny thing is that this little device now these days would cost very little, €4 or something like that, but it has 3 rotary encoders which can be used with a very high resolution, actually as high as you can make the separation, so the slits in between occlusion and opening. So you could do a tenth of a degree if it's a rotary encoder wheel and it's of big enough size. You could do amazingly precise rotational positioning in 3 dimensions, because it also had a jog wheel, and it is USB enabled, so it basically it transmits the data to the USB port of your computer. And USB port recognizes this as a printer, or a printer as a mouse, which has to do with the USB protocol, because it basically sends out a signal saying, okay, I'm device type number 1. And then it also has 3 buttons, by the way, so it also has button press inputs, which you could use to sense limits. It has 3 buttons, so you have 3 dimensions. Anyway, to make a long story short, I think that I could use this to make a true 2D, two-dimensional positioning system, at least, and then maybe a 3rd dimension by having a little engine going up and down, and then I'm not using rotary encoders, by the way, but I use linear encoders, which are simply strips of paper with black and white markings on them. And then, you know, that can be of arbitrary length in theory. What frustrates me about this a little bit is that, of course, it is a custom chip in this device. It is USB, so I cannot hack it into my microcontroller at this point. It runs at 8 megahertz. My microcontroller runs at 4 megahertz, and frankly, these things they're not fast enough to if they are basic driven, if they are coded from scratch with assembler, then of course they can do much more, but they cannot read out this position. The computer can, a Python script can. So I might ultimately, ultimately it would be a very easy way to implement your 2-dimensional positioning, with one caveat, and that is, of course, that this is a wired solution, so you would have a wire running. Now, one of the options I have is to simply purchase a wireless infrared mouse, and then you have you basically have yourself a 2D positioning device, because you can put it on a let's say, if you imagine this is one of the, let's say you have two beams like this, you put this on it. It's not a screwdriver, but it is a it should be simply something like a tube, like a cylinder, and you let the mouse you fix the mouse in position and you let it roll over the cylinder. Then of course it will be able to infraredly sense one dimension, and it will simply beam that to your computer, and you will be able to know where you are if you're rolling back and forth. If you at the same time you simply pull or drag the mouse over this cylinder, then you have your second dimension, and basically you have a 2D positioning system at about €10, which I basically have to purchase that and try that out. It would be nice if you can also make it so that it doesn't really show up as a mouse pointer, but it simply goes into your Python script. But that's basically a very simple way. And of course, if I learn a little bit more about these chips and I know where to find them and where to purchase them and how to hack into them from the microcontroller, so basically have a different type of output than USB, which I think will be hard to find. But or I find a way to use these infrared positioning, these encoders. Then of course they are almost everywhere in old mouse devices, so I simply take them out of this and use them with a microcontroller, and I have, let's say, two inputs dedicated to spotting the movement. So that's this aspect. There's many more, of course, because one of the things you want to have with your tracker is that you know what the position is. I'm a little bit wary of using these rotating resistors, but that's what I'm working on. What I'm actually working on is making it interactive. So I have a webcam now outside, pointed at the tracker. I will have a website that allows you to push a button and then you will start moving the tracker, but I have to rig it up basically, add the controls and the limiters to it, and then I'll have one of my computers, a very small one, will have to be online continuously in order to allow you to do that. But it is also, let's say, an interesting solution to the challenge of managing these systems, remote managing of these systems, of either concentrated solar power or heliostats. And why not, utilize the online community to do that, as well as probably at one time in the future gardening or remote gardening. So what the robo-economy, what I've been talking about, is that you can do things automatically, but you can also involve many people in doing it. And one way to make this whole project a little bit more interesting is to make it interactive. So hopefully I'll get that set up today, because one of the bottlenecks is that I have to talk to the microcontroller and from the computer and back, so that when you give a online signal and then basically it ends up on my computer, it has to be communicated through serial port to the microcontroller, and that is something that is not very smooth at the moment, because I basically wasted one microcontroller because I told it to listen to the serial input port, but that's also the port with which you program it, so it basically is now constantly listening to something and also outputting data to the serial port, while, and say, that's like a digital cacophony that you cannot get through anymore. So this chip basically locked itself up in its own script, and it's now useless. I cannot control it anymore. So that's let's say a €8 learning experience. But I'll put a link to the webcam below this. That's just a direct link to the image, and it will be a still image because I'm offline now. I'm going to work on the bigger laptop that I have. But hopefully I'll be able to allow control of the rig from by you, and eventually, and then of course it would be nice if you could have like say a temperature sensor in it, or something like that, or a luminosity light sensor, and then some gauges that you could basically see that what you are doing has an effect on these values. And then you would have immediately a whole system set up which could do a lot of other stuff, which would be a platform for a whole community of people that do this, have these rigs. And that's like a whole, basically, I'm trying to do a lot of things at the same time. Of course, printing with or melting sand is the ultimate aim, and this is simply to make people more enthusiastic and see more possibilities. So I hope it's interesting, and check out the link. It's a picture of a rig outside. It's a simple one, and hopefully with the rotary, with let's say the encoder method, with this LED infrared stuff, it is actually a very cheap thing to make. What you have then with let's say I believe about 10 euros microcontroller, the infrared LEDs, I believe you are about, and of course the frame and etc. and the motors, you're at about 50 euros for the rig that can be controlled remotely and maybe online, and then I'll make a standard, of course you have to have a serial cable, all that stuff. Make a standard setup that you can actually purchase and try out, and that you can share the information on what's happening with your heliostat, and maybe of course all the image uploading of the webcam, all that stuff could also be included. But for that I need time, and for time I need some cash, so I'm also doing some other projects in order to earn my keep. I hope you find this interesting. I hope you check out the other videos. I'll link to the Glass Revolution video below, the whole idea, and you support this, and you know, I think it's going to be fun as well, because I might make it so that you can fry some stuff from where you are, or see, let's say, the devastating effects of concentrated solar power. But thanks for listening, and I hope you enjoy it, and keep yourself posted on this on progress. And you know, if you are interested in copying it and etc., creating some kind of open source community around this, and you are let's say able to support it, then please do, because ultimately it will generate a lot of work and a lot of cash, or wealth, we have to say, you know, not oil, carbon credit cash, but simply wealth, independence, and prosperity for people. Thanks for listening.